So today we're going to talk about new method, okay? So look at the exam number 6 first, okay? So what is the name of this one? It is first order nonlinear, right? So let me write the name first, okay? This is first order nonlinear. Well, as you remember, I taught you only one method which can be applied to a nonlinear equation. It is separable. And look at the example first, one more time. And do you think that is separable? Take your time. Think one more time. Try. But unfortunately, you cannot separate the variable, which means there is no way to solve the problem. Okay, so that's why, we're going to talk about new method. The name of this method is the exact differential equation. Okay, so as I said, there is no global method which can be applied to the any kind of differential equation. Okay, it is really case by case, and this is also, it must be very good setting. Okay, well, but let me try to explain how we can use exact differential equation. Okay, so the idea is really similar with integrating factor. Do you remember when I explained about the method of integrating factor? Well, it was for linear equation. Okay, it was we wanted to have your left hand side as the derivative of the product function form, which is u times v prime is equal to u times v prime plus u prime times v. That was what we expected. And by multiplying integrating factor, we were able to make your left-hand side as a product form. That was the idea about the method of integrating factor, okay? But this case, your left-hand side, actually your function is nonlinear, which means it won't be product, the derivative of the product function form. So, but the idea is similar. Since it's nonlinear, we hope, we wish, inshallah, your left-hand side is the partial derivative form with respect to x. That is the idea, okay? So let me explain about this one a little more detail, okay? So first of all, let's say this term without y prime, let's say it is m x comma y, which is the function of x and y. And let's say the coefficient y prime is n x comma y. Okay, so the general form for the exact differential equation can be written by m x comma y plus n x comma y times y prime or dy dx is equal to 0. Your right hand side must be equal to 0. If it's not equal to 0, you have to move to the left hand side, and you have to include that one in the m function of m. Is it okay? It's in general, simply we can say just m plus n dy dx equal to 0 for. Okay. So as I said, we would like to make your left-hand side as the partial derivative with respect to t. Okay. So if there is the partial derivative of that, and we can say your left-hand side, okay, we just assume for now, okay, we can say it is, let's say new function which named psi. This character name is psi, and I said it's partial derivative with respect to x is equal to 0, right? This is my assumption, if it is possible, okay? And then since it is the partial derivative of your function psi, then we can just take the integral with respect to x on both sides. Then your final solution will be psi xy, and right hand side it was 0. The integral 0 is constant. So this will your final solution of your differential equation. Okay, this is the idea. Then how can you find your left hand side as the partial derivative of your function psi? Okay, so do you remember partial derivative, by the way? Okay, let me show it to you. Okay, so here we go. Then what is partial derivative of psi? Even we do not know about this one. okay? But let's assume there is, okay? Then that is equal to, like, this is kind of like, review of your calculus 3, okay? So what was it? D psi over dx times dx plus d psi dy dx. That's it, right? And as you know, dx equal to 1. So simply we can say that is equal to d psi dx plus d psi dy times dy dx. As I said, we are talking about your left-hand side of your differential equation, which means, let me write your differential equation like right below this one. It is m plus n times dy dx. Can you see it? We're going to do the matching game. Look at that. I'm talking about as if your m is exactly some function's derivative with respect to x, and your n is the function's derivative of y with respect to y, then beautiful. Then we can say your left-hand side is the partial derivative of your function psi with respect to x. Does it make sense? So this is very important. Look at that. Like, let me rewrite this one more time, okay? I can say your as long as your m is equal to psi x n is equal to psi d psi dy. Okay. One more thing. Let me take the derivative of your m to one more time. Then we can say my is equal to d squared psi over dx dy. Okay. Let me take the derivative of the second one with respect to x. Then we can say nx is equal to d squared psi over dy dx. Let me check one more time your calculus 3. And what about this one? D squared psi over dx dy and d squared psi over dy dx. As you know, the order of differentiation is not important for continuous function. They are same to each other, right? So what I can say is as long as your my is equal to nx, we can say your differential equation is exact differential equation. Do you understand so far? Okay. I summarized everything about this one below this. Okay. So like all these things are like what I explained. And also in theorem number 5, look at that. We're going to say your differential equation is exact differential equation if and only if your my is equal to nx. I'm talking about partial derivative. Okay. So like that's exactly what I like mentioned right before, right? So this is basic theory, okay? So like, whenever you finish this one, whenever you check like it is exact, which means your left-hand side could be the partial derivative form with respect to x, then what am I supposed to do? Your left-hand side is d dx psi xy is equal to 0. Then take the integral on both sides. Then final answer is the psi xy is equal to constant c. This is your final solution, okay? Keep that in mind. Your right-hand side must be unknown constant c. If you have initial condition, you can decide the c. That's it. This is basic idea about the exact.